Today we're going to be talking about the unit circle and how it relates to the trigonometric values that you were finding last time and just how everything relates when you're looking at the unit circle. So the unit circle, as its name suggests, is a circle that has a radius of 1. Now what this does is it helps us simplify our calculations because r is equal to 1. So remember last time we talked about finding the trig values of any angle, not just the special angles. And we talked about how you can find them if you have some point x comma y on the terminal side. Now, if we were working with x, y, and r, and we know that r is equal to 1, then all of our calculations will simplify. So here's our angle theta, and so sine of theta, which is y over r, in this case would be y over 1, so it's simply equal to y. Same with cosine. Cosine would be x over r, so that would be x over 1, so that would be equal to x. Now tangent is in terms of y and x, so tangent stays y over x. But what's neat is that now we actually have x and y giving us sine and cosine. So we actually have x and y giving us cosine and sine. So what's neat about this is if you know a point is on the unit circle, that actually tells you what the value of cosine and what the value of sine is at that angle measure. Let's go ahead and fill in this chart. Now at the top here, you'll notice that I've put in the chart that you absolutely have memorized up to this point for all those special angles. So we're going to go through the unit circle. I'll put this in degrees as well. So we'll start with degrees. We'll just go around the unit circle. We are going to put in all those special angles. So 30 degrees, 45 degrees, 60 degrees. Then here we're at 90 degrees. And then over here in quadrant 2, the ones that use 30, 45, and 60 as reference angles would be 120 degrees, 135 degrees, and 150 degrees. Then we get to here at 180 degrees. And then in quadrant 3 again, the values that use 30, 45, and 60 degrees as reference angles, 210 degrees, 225 degrees, 240 degrees. And then we get down here, that's 270 degrees. And then in the last quadrant, the ones that use 30, 45, and 60 as reference angles would be at 300, 315, and 330 degrees. Okay, so in radians, this would be 0, pi over 6, pi over 4, pi over 3. 90 degrees is pi over 2. All right, in quadrant 2, now we have 2 pi over 3, 3 pi over 4, 5 pi over 6, until we get here to pi. In quadrant 3, we have 7 pi over 6, 5 pi over 4, 4 pi over 3, and then down here we're at 3 pi over 2. And then in quadrant 4, we have 5 pi over 3, 7 pi over 4, and 11 pi over 6. Now, we know what those points are on each of those angles because we know the values that are up there in the upper right corner of sine and cosine, and we know what's positive and what's negative in each quadrant. So we're going to go ahead and label what the coordinates are on the unit circle at each of these angle measures. So starting here, this is 1, 0. Over here, this is root 3 over 2, 1/2, right? So these are your x and then your y value. So it's your cosine value, then your sine value. If it helps you to remember that cosine comes first, it's always in alphabetical order. So x comma y, cosine comma sine. So cosine of pi over 6 is root 3 over 2, sine of pi over 6 is 1/2. Then we have root 2 over 2, root 2 over 2, 1/2 root 3 over 2. Up on top, this is 0, 1. Then in quadrant 2, we have negative 1/2 root 3 over 2, right? Because cosine is negative in this quadrant. You can also think of it as well, the x-coordinate must be negative in quadrant 2. Negative root 2 over 2, root 2 over 2. Negative root 3 over 2, 1/2. And then we're over here on the left, negative 1, 0. On to quadrant 3. In quadrant 3, we know that the only thing that's positive in this quadrant is tangent. So our coordinates, which are x, y, corresponds to cosine and sine, they're both going to be negative. So negative root 3 over 2, negative 1/2. Negative root 2 over 2, negative root 2 over 2. Negative 1/2, negative root 3 over 2. And then down to the bottom here, we're at 0, negative 1. In quadrant 4, cosine is the only function that is positive. So that means our x value is positive, our y value is negative, which makes sense in quadrant 4. So 1/2, negative root 3 over 2, root 2 over 2, negative root 2 over 2, and root 3 over 2, negative 1/2. Now you'll see there is a pattern as you go around the unit circle, and it should be pretty easy, if you know your chart, to be able to fill this out. Now I'm not going to ask you to fill out this chart, although you should be able to, nor are you required to use this chart to find values of trig functions. So for example, if I asked you what sine of 5 pi over 6 is equal to, you could, on this unit circle, if you know it, just find 5 pi over 6, find the y-coordinate, and it's 1/2. Now you can also absolutely just use what we talked about before, where you use the reference angle, and you determine that based on its location in quadrant 2, that sine of 5 pi over 6 is going to be positive. What the unit circle is particularly helpful for are for those cases at 0, at pi over 2, at pi, and 3 pi over 2. Notice for those, we've never used any reference angles because reference angles are acute angles. They are angles that are less than 90 degrees. And so we aren't able to use reference angles for those points. But those points are actually pretty easy to find the values of. So if you were asked, what is sine of pi? You can look for pi on the unit circle. And since you're asked for sine of pi, you're looking for the y-coordinate of that point, which is 0. So sine of pi is equal to 0. Let's do some examples together. So example 1, evaluate the 6 trig functions for theta equals 5 pi over 4 using the unit circle. Now if you were to find 5 pi over 4 on the unit circle, it is in quadrant 3 of the unit circle, and you just need to write down, well, what are the coordinates of that point? That would be negative root 2 over 2 and negative root 2 over 2. Now, since you're finding all 6 trig functions, you can say, well, remember that x corresponds to cosine, y corresponds to sine, at least on the unit circle. And so sine of 5 pi over 4 is going to be negative root 2 over 2. Cosine of 5 pi over 4 is negative root 2 over 2. And then for tangent, this is going to be y over x. And since this is the same value, anything divided by itself is going to equal 1. And then for cosecant, secant, and cotangent, these are the reciprocals. And so just finding the reciprocals of each of those functions will give us our answers. So that would be negative root 2, negative root 2, and 1. Okay, example 2. Evaluate the 6 trig functions for theta equals pi using the unit circle. So when theta is equal to pi, on the unit circle, you're looking at the far left part of the circle. There, the coordinates are negative 1, 0. Again, remember x corresponds to cosine, y corresponds to sine. So sine of pi is equal to 0, cosine of pi is equal to negative 1, tangent is equal to y over x, so that's 0 over negative 1, which is 0. And then the reciprocals, you just find the reciprocals of sine, cosine, and tangent. So the reciprocal of 0 is, well, we can't have 0 in the denominator, so that's going to be undefined. The reciprocal of negative 1 is negative 1. And then the reciprocal of 0 is, again, undefined. All right, last example. Evaluate the sig trig functions for theta equals 3 pi over 2 using the unit circle. Okay, so again, on the unit circle, 3 pi over 2, where is that going to be? It looks like it's on the bottom of the unit circle, where the coordinates are 0, -1. Again, x corresponds to cosine, y corresponds to sine. So sine of 3 pi over 2 is equal to -1. Cosine of 3 pi over 2 is equal to 0. Tangent of 3 pi over 2 is y over x. That's -1 divided by 0. That's going to be undefined. And then find the reciprocal. So cosecant of 3 pi over 2 is -1. Secant of 3 pi over 2, that's undefined. And then cotangent of 3 pi over 2, well, if it was y over x before, now it's x over y, so this is equal to 0.